Hello everyone. Today I want to introduce the concept of Bayes' theorem. So Bayes' theorem is one of the most important theorems in probability, and it's pretty old. So this is a theorem from about the 1700s, and the theorem is stated as thus: the probability of event B happening given knowledge on the event A is equal to the probability of event A given knowledge on event B times the probability of event B over the probability of event A. So one interpretation of this theorem is that it essentially allows us a way to calculate how a probability of B is changed given more information. So you'll often hear this value be called the posterior probability. So this is essentially a probability of event B post us gaining information on event A, and this is the prior probability. It's the probability of event B prior to us gaining more information. So essentially, this theorem allows us to update the probability of event B given that we have more information. Now, one use of Bayes' theorem is regarding a famous television show problem called the Monty Hall problem. So Monty Hall, spelled thusly. And this problem was thus. You have three doors. Door number 1, door number 2, and door number 3. Now behind one of these doors, just put here now, is a new car. But behind the other two are goats. I'm going to make a little goat horns here and some goat horns here. Now the goal is, of course, to get the car. And the way this game works is it's split into 2 rounds. In the first round, you pick a door. And in the second round, a goat is revealed prior to you picking again. A goat is revealed behind one of the doors. And a goat has to be revealed. So goat revealed behind one of the doors. In this case, one of these 2 doors would be opened to reveal a goat. If you chose door 2, then door 3 would have to be open. The door that you chose will not be opened. So let's write goat revealed behind door not chosen. And at this moment, you have 2 options. You can either stick with your first guess, you can stay, it's called option stay, or you could switch to the door that you haven't chosen yet and that, of course, does not have a goat revealed behind it already. So what should you do? Well, let's apply Bayes' theorem to this problem. Let's say event A is the event the goat is behind door 1. I'll just mark it as D1. And event B is host reveals a goat. Now, let's find the probability that the goat is behind door 1, given that the host has revealed a goat. So essentially, this would be the probability of the goat being behind door 1, given that we are now in a round 2 decision, staying or switching. So using Bayes' theorem, we have that this is the same as the probability of the host revealing a goat, given that the goat is behind door 1, times the probability that the goat is behind door 1 over the probability that the host reveals a goat. So probability that the goat is behind door 1 is actually quite easy. Initially, in the first round, there are 3 doors, so you have a 1/3 chance that the goat is behind any given door, so PA is just 1/3. Now, PB, the probability the host reveals a goat, is actually the same as the probability the host reveals a goat, given that the goat is behind door 1, because the game stipulates that the goat is always revealed. A goat is always revealed. So this is actually just 1. So therefore, the probability the goat is behind door A, given that the host has revealed the goat, is actually just 1 times 1/3 divided by 1, which is just 1/3. So it hasn't changed at all. But notably, this also means that the probability that the goat is not behind door 1, presumably the door that you've chosen initially, is 1 minus 1/3 after a goat has been revealed, which is equal to 2/3. But you already know which door has a goat behind it of the other 2 doors that you haven't chosen, right? You know that a door that you haven't chosen has a goat behind it, so therefore you're essentially making a choice between 2 doors, given that if you pick door 1 in the first place, with door 1 having a 1/3 probability of being the door with a car behind it, and the door that you haven't chosen but hasn't revealed to have a goat behind it has a 2/3 probability. So therefore, you should always switch. Boop, boop. Now you know the right decision in the multi-hull game.